Hey everybody. So as you can see by the title of this slideshow, this is Introduction to Algebra Tiles. As part of our algebra challenge, we're going to use algebra tiles to visually model what's happening with the various things that we're doing, such as combining like terms, which we'll do today, solving for variables using distributive property and that type of thing. You can see I have a picture on this of what you would get if you ordered a set of algebra tiles from a math company. This picture comes from a company called Hand to Mind, and we have several of these in the school that are used in the 7th grade, 8th grade, and algebra class. So you'll see these in future years. And the cool thing about this is you can work with them physically. But remotely is fine too. We've got several online tools. What I want to do, though, before I delve into that, is I want to go over a couple of things that are important to remember when you're working with algebra tiles. First, algebra tiles use the area model. So we'll be doing this a little bit more in geometry, but I just wanted to go over area with you real quick. As you can see, area is the number of square units that cover a flat surface. And what we mean by square units is this right here. This square unit is 1 by 1 by 1 by 1. If it represented a square inch, it would be 1 inch by 1 inch by 1 inch by 1 inch on all four sides. If it represented a square meter, it would be 1 meter on all sides, right? This is used a lot in the real world. For example, let's say I was trying to figure out how much carpeting I would need. Let's say my area that I want to carpet was a portion of my classroom that was 5 feet by 3 feet. So I would need to know how much carpeting I'd need to order. So what I would do is figure out how many square units that was. So you can see that you've got basically 3 feet here, 5 here. So we've got 5 3 times. So 5 times 3 is 15. This is very similar to what we work with when we're working with young children, when we're trying to teach them how to multiply. We build something called arrays. Area and arrays, same thing. Right? So you can see that multiplication works, which is why the area formula for a rectangle is length times width. This right here is how we would write square units. Note there is a little exponent here. I'm going to be talking about exponents a little bit more and the differences between exponents in situations like this and when it's after a measurement unit. Let's say all of these represented an inch, so these were all square inches. Then the area of this would be 15 inches squared. Or I was talking about feet. If it was feet, it would be 15 feet squared. All right, I want to go over here and talk about exponential notation a little bit. And then I'm going to come back to the difference between exponential notation here and here. All right, so exponential notation is a way to write numbers if we're multiplying them by themselves. So 4 to the second power is 4 times 4. We also refer to that as 4 squared sometimes because a 4 by 4 would make a square. 4 to the third power, 4 times 4 times 4, and that's equal to 64. Sometimes when we have something to the third power, we call it cubed because you can think about a 4 by 4 by 4 cube, for example. So those are the only ones that have special names like that. 4 to the fourth power, 4 times itself 4 times, 256. So I'm hoping you have the idea here. Here's 5 to the third equals 125. I do want to show you this, though, because this becomes important in the algebra tiles. If we have x times x, we would refer to that as x squared. Or we can think about it physically as a square with sides of x. X times itself 3 times is x cubed, or x to the third power. X times itself 4 times would be x to the fourth power. Right? Let's go back to this real quickly, though. If we have a measurement unit and then an exponent, that means something a little bit different than this here. I have had students look at this and they think they have to square the 15 or do 15 times 15. That's not the case. If there's a measurement unit and then there's a little exponent too, it's just telling you that instead of talking about 15 inches, we're talking about 15 square inches or 15 of these squares. This just tells you it's an area measurement, not a measurement of length. or think about this as a two-dimensional measurement instead of a one-dimensional measurement. I wanted to share these buttons with you real quick. These are buttons on various calculators that will give you values of things like this. So let me show you on this one. This has a y to the x button. So let's say I was actually trying to figure out what, say, 8 to the 4th power was, right? So that's 4,096. Here's how I did it. I want 8 to the 4th power, so I do 8, hit the y to the x, 4. It equals and it tells me, all right? This calculator, clear this out, you can see I did 5 to the 8th power before. Let's see, how do I clear this one out? Just hit the refresh button. All right, so for this one, let's say I wanted to figure 5 to the 8th power. It's x to the y button we want here. And one thing I like about this calculator is it spells it right out for you, 5 to the 8th power. Right? You can see I practiced those a little bit ahead of time. Okay, so that's enough to get us started on algebra tiles. What I'm going to do is show you this first. This comes from Desmos Graphing Calculator, and I'm going to show you how to get to these tiles online, but I want you to see there are 6 tiles shown here. I'll come back to this a bit and talk to you about how to use these, but I want us to take a look at what each of these tiles means. So these tiles use the area model. This is what we call our unit tile. It's 1 by 1 by 1 by 1, so it is 1 square unit. This rectangle is x by 1, so this stands for the value of x. This tile is x by x, so x times x is x squared, so that's the area of that one. And then we actually have another variable in our algebra tiles, y times 1, you can see this is y squared, y times y, and then there's another one that's x by y, so we just call that the xy tile. All right, so if you look at this, there are various backgrounds. For this particular piece, I'm going to use no background. For another one, I'm going to use what's called an expression mat. It's got a plus and a minus, okay, but I'm going to go back to no background here. And then I'm going to hit the algebra tiles. Okay, so let me start with this. So here's my unit tile and my x tile, and I just want to show you that the 1 matches up with that one side of the x. So this length is x, this length is 1. Another thing, if you double click the tile, they turn to a horizontal position. I'm going to try to just measure up the units here. So you can see by looking at that it doesn't match any of the units. Like I can't say that it's exactly like 2.5 or anything like that. That's because we want our x to be unknown. So they purposefully do it that way. Same with the y, going to double click that, turn it horizontally. You can see the y also does not measure up to any of these. All right, but the y tiles are 1 on one side, y on the other, so that's why this is equal to y. All right, so the y squared tile is y by y, so you can see that. The x is the same, x by x. Right, so that's how you get x squared. And then as you might imagine, this is x times y. X is generally the shorter side, y is generally the longer side. Right, and then I think you saw just what happened there. Any of these tiles, if you click them once, they turn to negative, and I want you to notice what happens when you're looking at the negatives here. They're all what color? Yeah, red. So all of the tiles, if you had the physical tiles, would be red on one side. Red is always negative. Here it tells you, if we were working with the algebra tiles by hand, it wouldn't say negative, but it's just one of those things that you're expected to know. Okay? All right, so let's go back to this. What we're going to do is we're going to work on 2 combining like terms problems. One is going to be an addition problem, this one here, and one is going to be a subtraction problem. Okay, so I have set up this one right here. It is 2x plus 3 plus 4x minus 5. So note that I'm thinking about the minus 5 as 5 negatives. That's really a good way to be thinking about subtraction problems at this point is combining negatives. All right, so let's go back to the slideshow. So you can see here, right, sort of similar setup. I didn't have them exactly in a row, doesn't matter, all right, but 2x plus 3 plus 4x minus 5. All right, so the next thing I want to show you is something called zero pairs. We'll be talking as time goes along about legal moves with algebra tiles. One legal move is to set up zero pairs. And when you have zero pairs, you can delete them. Why? Well, because a 1 combined with a negative 1 is a 0. If I had x combined with negative x, that would be 0. Each negative wipes out a positive because when they combine, they make 0. Okay, so I don't know if you saw, but I dragged my cursor over that whole thing. You can see it's all lit up in yellow now. I'm now going to hit the delete button and those will go away. And that's okay to do because they were zero pairs. They're worth nothing. And now we have our answer. We have 1, 2, 3, 4, 5, 6 x's and 2 negative 1s. So my answer would be 6x minus 2. Right, and then if we look at our next slide, you can see here are the zero pairs, right? And then getting rid of them, here's our answer, 6x minus 2. You can see if you did this out without the algebra tiles, you would have had the same thing, combining like terms. You can add the x's, 6x, and you can combine these, the 3 with the negative 5. The great thing, though, about the algebra tiles is they give you a visual model. Okay, so we're going to set up another problem. We're actually going to subtract this now. So this one is the same as 2x plus 3 minus 4x minus 5. I want you to note that on the equation map, I have put all of this down in the subtraction section. So I do have this set up in the tiles, just like this, right? And what I want to do is talk about the next legal move with algebra tiles. You've done some work with negatives, and I want to remind you that subtracting is the same thing as adding a negative. For example, if we had 4 minus 7, right? That's the same as combining 4 and 7 negatives. So 4 minus 7 is the same as 4 plus negative 7. It's the same as adding the opposite. All right, well, this is how this works with the algebra tiles. If we have a subtraction here, we can put it up in the addition part, but just change the sign. So this is what we would call flipping it. If we had the actual tiles, we would just flip them right over. Right here, I just have to click them. Same with the negatives. Subtracting a negative is the same as adding a positive. So I'm just basically flipping each of these over as I put it in the addition section. Right, and then we can go back to our zero pairs. There's a zero pair, there's a zero pair, and we can get rid of them. Now we have our answer. We have 2 negative x values, and we've got, if we count these all up, we've got a total of, it looks like 8. So I just kind of like to line things up like this, just so I can see it a little bit better. All right, so they always attach when I don't want them to. All right, so yeah, we've got negative 2x plus 8. All right, so let's see what happens here. We've got the problem set up. Okay, so right here, I want you to notice what happened when I flipped the tiles up with the equation. We still have 2x plus 3, but now we have minus 4x plus 5. When we're subtracting something in parentheses, basically what we do is we just flip the sign of each thing inside the parentheses and then add it. Right, so really what we're doing is adding a negative 4 and adding a 5. But you can see how what we did here in terms of flipping it translated to this. Now we have 4 negatives and we have 5 positives. We'll talk more about this later. I'm just hoping that you can see how the algebra tiles work. And then you can see here what we have is 2x plus 3 minus 4x minus 5 is equal to negative 2x plus 8. All right, so there's your introduction to algebra tiles. We'll be using these more. I will say right here, you can clear the tiles out if you need to, if you're trying to start over. We'll be looking at a variety of backgrounds. We'll be looking at an equation map to do some